So these are the answers to the meets exceeds level questions for target 3 on solving systems of linear equations. You have a choice here. One method is to take this bottom equation and solve it for y, and then use substitution. So if I solve this for y, I'm going to get 2/4 x, which reduces to half of an x, plus 8/4, which is 2. So I'm distributing that divide 4 to both of those. Then I can substitute that in place of y into the first equation. So when I do that, what I will get is x over 2 plus x over 2 plus 2 all over 3 equals 5. Now you could deal with this directly with the fractions. You have x over 2 divided by 3. That's divide 2 and divide 3. That's like dividing by 6. Or you could think of that as x over 2 divided by 3 is times a third. So that's how you get x over 6. Plus 2 divide 3. And you could get a common denominator of 6. And you would get that by multiplying this fraction by 3 over 3 and this fraction by 2 over 2. So you'd have 3/6 x, which is the same as half of an x, plus 1/6 x, plus 4/6, which is the same as 2/3. 2/3 is the reduced form of 4/6, equals 5. So then I have 3/6x plus 1/6x, which is 4/6x, plus 4/6 equals 5. And then you could solve this by subtracting 4/6 from both sides, and then multiplying by the reciprocal 6/4. But there is an easier way, and I could have done this actually early on in the problem. If you want to solve an equation that has fractions in it, you can multiply both sides by something to cancel those fractions. Basically, what would be the least common multiple or any common multiple of the denominators? So in this case, I have a 2 and a 3 in the denominator. 6 is a multiple of that. So I could have done this earlier on, but I'm going to do it right here. You can do this. You can multiply any equation by anything you want, as long as you do it to both sides of the equation. So when I multiply the 6 to the 4/6, the 6's cancel and I get 4x. And the same over here, when I distribute the 6 to the 4/6, the 6 cancels and I get 4. But then I have to multiply this side by 6 too. So I have third. So now it doesn't have any fractions. So I could subtract 4 and divide by 4, and I get 26/4, which divided by 2, each of those, you'd get 13/2. So that's x. Once you have x, then you're going to substitute that in. 13/2 for x divided by 2 plus 2. So you're dividing by 2 and then dividing by 2 again. That's like dividing by 4. So that would be 13/4 plus 2. I'm going to get a common denominator of 4. So I'm going to multiply this by 4 over 4. You agree that 8/4 is the same as 2. So now I have 13/4 plus 8/4 is 21/4. You add the numerators and keep that common denominator. And then if possible, you reduce these fractions. Now if you left it as a decimal, it would be 5.25, and it would be 6.5. That one's not too bad to change to a decimal, but if it was some sort of number where the decimal repeats, you wouldn't want to round that off. The other typically is a little easier when you're dealing with fractions, is elimination. So what I'm first going to do is get them both in standard form. So I'm going to subtract the 2x from both sides. Basically, that 2x moves over to the other side and becomes negative. So now they're both in standard form. And now I just have to find a way to eliminate something. So I'm looking at this, and I'm seeing, hey, I could multiply the top equation by 4, because if I take 4 times x divided by 2, I get 2x, which is the opposite of the negative 2x below. So I'm going to do that. And I get 4y over 3, and I get 20. And then the bottom, I left alone. So now I realize I'm going to have fractions again, right? So if I want to get rid of those fractions, I can multiply this whole top equation by 3 to get rid of that fraction, which basically I could have done by just multiplying the original by 12, because I'm multiplying by 4 first and then 3 later. And I'd get 6x plus 4y equals 60. Because remember, you can multiply any equation by anything you want. So I'm doing that just to eliminate the fractions. And then I realize, but if I do that, what happens? Now my x's aren't the same, right? So I think I should have also multiplied the bottom one by 3, if I'm going to do that. So let's start this over here. So I multiplied the top by 3 just to get rid of the fraction. But then I'm going to have to multiply the bottom by 3 as well to make that a negative 6x. And I can do that as well. There are definitely many other ways to do that. So now I have opposites in the x's, so I can add. The x's will eliminate. I get 16y equals 84. Divide both sides by 16. Now I'm going to have to reduce this because I got rid of fractions by multiplying by bigger numbers. So looks like 4 goes into both of those. 4 goes into 16 4 times, and 4 goes into 84 21 times. And look at that, I got the same y value I got using substitution. And I could do some similar method to eliminate the y's. And I should get the same x value of 13 halves. So don't be surprised if you see some fractions with some of these. Now as far as the word problem goes, for number 4, you have to show your equations. So to come up with the equations, you really have to first figure out what are you trying to find. And the question here is pretty straightforward. How many adult tickets, I'm going to use the variable A for that, and how many children or senior tickets were sold. So children and senior are the same price. So I'm just going to call those together C. So A is the number of adult tickets sold, C is the number of children tickets sold. And as I read through the problem, what they're going to do is they're going to give me 2 pieces of information that each allow me to write an equation. One piece of information is about the total number of people. So the feeder sold 62 tickets to the show. So the number of adults plus the number of children/seniors has to equal 62. That's one equation. It has 2 variables in it, 2 unknowns. But we can solve it as long as we have a second equation with those same 2 variables. And that's where the other bit of information comes. Is they brought in $440. And these affect that as well. These are all dealing with money. They're getting $8 per adult. So I'm going to take the number of adults times $8 per adult. And I'm going to add to that the number of children or seniors times $6 for those tickets. My clue here is that this has the word per. Per means multiply, so that 8 is getting multiplied by a variable. So is the 6. So then our total money in is $440. There's our system. Now that that system is set up, you just choose a method to solve it. I'm going to choose elimination. So I'm going to multiply the whole top equation by -8. So I get -8a plus -8c equals 62 times 8 is -496. 62 times -8. And then I add that to the bottom equation. So the C's the A's cancel. And then I can divide by -2, and I will get 28 is the number of child tickets. So if that's the number of children tickets, I can substitute that in for the C, or basically just do that in my head. If 62 people came and 28 were children, well, how many were not children? So that would be what, 34?
Yep.
So then these two numbers definitely satisfy the first equation, the number of adults. But to check my answer, I'm going to make sure that that would equate to the $440. So I'm going to plug those into the second equation. $8 times 34 adults plus $6 times 28. And if this is 440, I know I'm correct. And it is. Questions?